My name is Holly Arnold, and I'm the math interventionist at Mission West Elementary. Today, we're going to talk about how we can use both models and equations to multiply fractions.
In fifth grade, students are expected to be able to multiply fractions by a whole number or a whole number by a fraction. First of all, we need to understand why we might need to multiply fractions. The first reason is repeated addition. Just like whole numbers, if we are adding the same numbers over and over again, it might be faster and easier to multiply the numbers instead. This might look like 2/3 plus 2/3 plus 2/3 would be the same as 3 times 2/3. Another reason we might need to multiply fractions is if we are looking for part of a set or part of several wholes. We could multiply the number of parts to find the whole amount we need. Let's look at our first example. 4 times 2/3. Now, when we look at this, we can think of this as four groups of 2/3. And there's two different models that we're going to use to show, or that we could use to show this equation. So I know the first one that I'm going to look at is a number line. So a number line is always going to have a beginning, an ending, and then we need to figure out how many spaces we're going to need. In this case, we have four wholes or four groups. So we're going to make sure that we have four groups on our number line. So I can label this 0, 1, 2, 3, 4. And I know that I'm working with thirds. So each group or each whole, I'm going to split into thirds. This will make it easier for me to jump on it when I'm doing my repeated addition, because we did say that we can use multiplying fractions just like repeated addition. So I have my number line, and the first thing I'm going to do is I'm going to jump 2/3 because I have four groups of 2/3. So we're going to do 2/3 four times. So I start at 0. Each one of these is 1/3 each space. So we're not counting the lines, we're counting the spaces as we jump them. So this would be 1, 2. That's one jump. 1, 2, two jumps. Remember, I need four groups. 1, 2, 1, 2. So wherever I landed here, this is going to be my answer. So I can look and say one whole, two wholes. This would be 2 and 1/3. This is 2 and 2/3. So I can say 2 and 2/3. Or if I go back and count the thirds, I have 1, 2, 3, 4, 5, 6, 7, 8 thirds. Now, we can also look at using an area model or a bar model to help us with this. So I'm going to create my bar model. It's going to be the exact same length as my number line. That's just going to help me line everything up. Okay, so now I have my rectangle or my area model, and this is going to have four sections in it. So just like we did at the top, exactly where we have our whole numbers, we're going to label those. So this would be one whole, two wholes, three wholes, four wholes. And I'm actually going to go ahead and draw my lines in so that I can see where the thirds are, because I'm going to be using groups of thirds. It'll be easier if they're already marked for me. Now, I have my thirds, so I can go ahead and start marking my thirds. I need four groups of 2/3. So I can have, this will be 2/3 right here. That's one group. This will be 2/3, two groups. This is 2/3, three groups, and then right here is 2/3, four groups. So I have 1, 2, 3, 4. Now I need to figure out how much is this really worth. So if I look at this again and go back to where my lines were starting with my groups, this is one whole. This is one. From here to here was another 1. And then I have 2 out of 3, 2/3 here, which would also equal 2 and 2/3. Now, if I wanted to look at the equation that I could write for this, if I had mastered doing the models and I was ready to just use the equation, I could write it like this. I have 4 wholes. I cannot multiply a whole number times a fraction just like it is. So I'm going to have to turn this whole number into a fraction. So I have 4 over 1, which represents the same as 4 wholes, times 2/3, because it's already in a fraction. And then I can multiply straight across. 4 times 2 is 8. 1 times 3 is 3, or 8/3, which is the same as what I got up here. Now, I can leave it as an improper fraction, but if the directions ever told me that I needed to change it into a mixed number, I could always do that. I would figure out how many times 3 fits into 8, which we know is 2, and then we have 2/3 left over. So this is also 2 and 2/3. Or I could show 8 divided by 3. 3 goes into 8 2 times. 3 times 2 is 6. That leaves me 2 left over, which would give me 2/3 because I was dividing by 3. 2 and 2/3. 2 out of 3 were left over. Let's look at another example. This time I have a fraction times a whole number. As you can see, I've already drawn my models to help us save time, and I have groups of 5. So 5 wholes. And I'm going to be multiplying 1/3 times 5. 1/3 5 times. So just like we did on our previous example, we're going to be using this number line to jump. So I have my whole numbers, but I'm going to need to divide it into sections of 1/3. So we're going to go ahead and do that all the way down. I can go ahead and do that on my bar model or my area model also. Exactly where my hash marks are up top, I'm just going to use those same lines to draw my ghost lines here. I'm going to go back up to my number line. Let's start with that. I'm going to jump 1/3 5 times. So I'm looking at my model here. I have 1/3, 1/3, 1, 2, 3, 4, 5. And this will be where I land. I know that I have 1 whole. This would be 1 and 1/3. This is 1 and 2/3. So my answer up here would have to be 1 and 2/3. Or I know I'm counting in thirds. If I wanted to do an improper fraction, 1, 2, 3, 4, 5/3. Okay, now let's look at our model down here. Let's say that I have my 5 wholes and I want 1/3 of each. So let's pretend that these are cakes and 1/3 of each cake was eaten. I could say 1/3 of this cake was eaten, 1/3 of this cake was eaten, 1/3 of this cake was eaten, 1/3 here, and 1/3 here. Now, this is just a different way to show this area model. Once I have all of my sections in each hole finished, then I can go back and count them. So I know that this is 1/3, 1/3, 1/3, 1/3, and 1/3. I can kind of use visualization to move some of these pieces around. So if I took this third, I could move it to this blank space and get rid of this. I could take this third and move it to this blank space and get rid of this. That means that this whole thing would be full. So that would be 1 whole. And then I could already see that I have 2/3 left over. I could even move this if I wanted to, get rid of this one. And this would be 2/3, which is what we got up here, 1 and 2/3. That's just one way. I know this is a lot of crossing out, but this is kind of what I was thinking in my head as if I was virtually moving them over. I just wanted to show you an example of actually doing it. Now let's go back and look at how I would do this as an equation. So I have 1/3 times 5. But just like we talked about on the last example, I can't multiply a whole number in this case. I have to turn it into a fraction. So I can put 5 over 1 or 5 wholes, and I can multiply straight across. 1 times 5 is 5. 3 times 1 is 3. So 5/3. 1, 2, 3, 4, 5/3. Or I could do the same division that I just did. I could take, if I want to change it into a mixed number, I can take my 5 divided by 3. 3 goes into 5 one time. 1 times 3 is 3. That means I would have 2 left over. And move that up here. I have 2 pieces left over, and we're counting in thirds. So 1 and 2/3.
Thank you for taking the time to join me for this lesson. I hope you find this helpful when you are working with your student. See you next time.